Hello people and welcome back to another video. In this video, we'll be starting from where we left off in the last video. So in the previous session, we went over the fundamental concept of statistical inferencing and one of the key tools which we have at our disposal for statistical inferencing, which is confidence interval. Now, in topic of confidence interval, we have seen the role that margin of error plays in confidence interval. So in this session, we'll be looking at margin of error in a little more detail, and we'll be understanding a few finer nuances that is associated with the margin of error. So without further delay, let's begin this session. So if you remember the previous session, we discussed about the generic idea or the generic formula of a confidence interval, which is estimate minus margin of error, that is the lower bound, and estimate plus margin of error, that is the upper bound. Now, what is an ideal scenario of a good confidence interval? So I'm going to be removing this. This is part of our previous session. So if we have a sampling normal distribution, this is my estimate, and this is my confidence interval. This is the lower bound, estimate minus margin of error, estimate plus margin of error. So this distance right here, this is my margin of error. This complete width, this is called precision. It is sometimes referred to as precision, sometimes it is referred to as width. Both the terminologies are okay. So ideally what we want is we want a small width with high confidence. Let me repeat. Ideally, we want a small width of the interval with high confidence. So the less the precision or the less the width of the interval with higher confidence, the better the model or the better the results. So keeping this idea in mind, if I have to write, it's already written over here, if I have to understand the factors contributing to margin of error and the way they change affects the margin of error. So how do I or we want them to change in a way where it will positively affect the result of our confidence interval? So let me reiterate what I said. Ideally, we want a small precision or a small width of the interval with high confidence. So this width, if it's small, the smaller it is, the better it is for us and the better the results. So your margin of error is the test statistic into sigma by root n. So if you look at this precision or the width, it comes out to be twice into margin of error. How? Subtract estimate plus margin of error minus estimate minus margin of error. You will get twice into the margin of error. So margin of error is given by z sigma by root n. Now we need to minimize the precision. If you multiply this by 2, you'll get your width or precision. So width or precision is directly proportional to z directly proportional to sigma and inversely proportional to the number of samples. Therefore, because we want a smaller precision or a smaller width for our results, we would ideally want a less value or a smaller value of Z statistic, a smaller value of sigma, and higher value of the number of samples. This is ideally how we want our input to be. Moving on, margin of error is also referred to as the half width of the confidence interval. So if my confidence interval is twice into margin of error, then what will be the half width? It will be nothing but equal to the margin of error. We've already seen here. So just to reiterate what I'm saying, this right here is margin of error. This point right here is estimate plus margin of error. This point right here is estimate minus margin of error. And so this width right here, because this is equal to the margin of error, and this width is equal to this width, which is why margin of error is referred to as the half width. Now let us look at an example. Suppose the executives would like to estimate the average amount of time callers are on hold before they reach a customer service representative by computing a 95% confidence interval. As before, the population standard deviation of the wait times is 15 minutes. The executives would like the half width of the confidence interval to be 1 minute. How many callers must they sample to get their 95% confidence interval to have the desired width? Let me remove all of these. My sigma is given as 15. My half width or margin of error is given as 1. My confidence interval for this question is 95%, right? So I want to calculate the desired width. So no, I'm so sorry. We need to calculate the how many callers, how many callers. I'm so sorry. We need to calculate the value of n, which is the number of callers. Now you already know that margin of error is equal to z into sigma by root n. You have been given the half width or margin of error. You have been given the population standard deviation as 15. Let me see again, it's 15. Yes. And you need to calculate n. So n will be nothing but equal to z into sigma by margin of error whole square. It's just cross multiplication, basic. Let me remove everything that is down. So I have sigma, I have MOE with me. I have this table of the critical value Z corresponding to the confidence interval. So for 95% confidence interval, my Z value is 1.96. I multiply that by my sigma, which is 15, and I divide that by my half width, and I square this to get my answer. So I hope this example is clear to you. We'll end this session by a small note. You all might be thinking that, do I need to memorize the Z values for all the different types of confidence intervals? The answer to that question is no, you don't have to. Just for this question, we have this table and we are utilizing this table. But when we will discuss Z statistic or critical value in a little more detail, I'll, we will be looking at the different ways in which we can actually calculate the critical value Z. So you don't have to memorize it. For now, just wait for a couple of more sessions, and I ensure you that by the next 3 to 4 sessions, you'll be able to calculate the Z statistic for any confidence level on your own. With that said, thank you so much for watching. I'll see all of you all in the next video.